Hey everybody, I'm Valentin. You can follow me on Twitter at Valentin Mihov. Also, please come and talk to me on the hallway. This is my biggest conference I've ever been. My interest includes snowboarding, algorithms, data structures, 3D printing, Internet of Things, so just come and talk to me. On this presentation, I'm going to tell you about some machine learning that we do in AirHelp. But let me first tell you what AirHelp is about and what's the business, because you need to understand that in order to get what we're trying to achieve here. So basically, AirHelp is a website that helps you get your compensation from the airlines. So when you travel by plane and your flight gets delayed or canceled, you're eligible for compensation. But usually, airlines don't want to give you your money. So you go on AirHelp website, you file a claim, and we handle that for you. So the business of AirHelp is concentrated about handling as many flights as possible. So the more flights we get, we can match them against our database with delayed or canceled flights, and we get more revenue. So at some point, like about 2 years ago, we built this thing called email scanner. So the idea is that you hook up your mailbox to AirHelp. We search for emails that contains flights for the past 3 years, and we tell you whether, like, for example, 2 years ago, you've flown from Warsaw to Rome, your flight got delayed, it was crap, you know, and you can claim your compensation. So the idea is that you hook the mailbox, we search it, and we send the emails that look like they contain a flight to a third-party vendor that parses the email and returns the result back. We match it against our database, and for the emails that are disrupted or canceled, we send you an email. Now, when we when we have a mailbox, we see a bunch of emails, and we can't send them all for parsing because our third-party vendor won't be happy and we'll be paying a lot of money. So we need to somehow figure out which emails contains flights and which doesn't. And the first approach that we took, like the easiest one, was we compiled a list, like thousands of domains of online travel agencies and other entities that sell tickets, and we look for emails that come from them. Now, this sounds great, but the success rate that we got is like below 25%. And this is usually because these companies send you a lot of marketing email. So we want to filter that out. Now, when we were building that, we were still at the early age startup. We didn't have much time and budget. So we had to figure out an ad hoc solution to filter out these marketing emails. So the approach we took is that we look at the subject of the email, of all the emails that are like marketing emails and don't contain flights, and we looked for words that appear there, and they appear only in emails that doesn't contain flights. And when we analyzed the data, we found that there are words with really high spamminess rating, if you call it like this. So words like sky miles, hotel, you know, basically if you see these words in the subject, then this is not an email that contains a flight. So when we implemented this solution, we got about 50% success rate, which was great for our third-party parsing vendor. They were happy and everything was good. So we just deployed that and it was working. Now, as the time went by, the performance of this thing started to decline. And this is normal because as the time goes, these companies, they start to send you different marketing emails that we haven't evaluated in our analysis. So the performance will start to decline. Now, we knew that we had to have a better solution, and we knew that we were going to have something more complex. But before we went into implementing something more complex, we actually did a little bit of refactoring. And this is extracting the part about deciding whether an email contains a flight or not and sending it for parsing to a microservice. And we deliberately choose Python for this microservice because we knew that probably we'll be doing some machine learning stuff for it. And I can tell you, Python is great for building machine learning. The ecosystem is great. So if you really are into building something like that, something that would be artificial intelligence or anything, use Python. And it's great because it's a general purpose language. So it's very easy to productionize your models after that. Like for us, we have a simple REST service, and then when we build the model, we just plug it in, and it was just working. Also, we found that Python 3 is really great. So go with Python 3, especially if you're processing text. Python 3 is great for processing text because of these encoding supports and stuff, which is lacking in version 2. So in order to build this machine learning model, what we did is we first generated a data set of emails that we're going to work with. Then we do pre-processing of these emails. Then we train a model, evaluate it, see what are the results, and basically do this swoop several times. And this way, improve the model over and over again. Now, a very important step of this whole process is the pre-processing of the emails. And by pre-processing, I mean you take the raw email, the raw data, and you process, like you strip all the data that you know that you're not going to need. So for the emails, this is basically stripping all the headers, all the protocol data in them, and just having the text. This is probably the most important part of the whole process. Like, it's not the algorithms, it's not anything like that, it's the pre-processing. So the results that we got after building a model and deploying in production were really astonishing. Like, we got like 98% accuracy, like being able to find 98% of all the flights. We removed all the ad hoc filtering, like the subject filtering and anything like that. We also saw like over 4-time decrease of the number of emails that we sent for parsing. You can see this graph. It's from Kibana, our monitoring system. You can see like the day when we deploy that, this is the amount of emails that we sent for parsing. So it dropped significantly. And basically, this approach is like much more general approach. It's like a black box that you train, and it will just work. It's really amazing. We had some very interesting findings when we were doing this thing. The pre-processing stage was really the most important, I think. So probably you heard that many times. For machine learning, it's garbage in, garbage out. You really need to process your data properly and feed the algorithms the correct data. So really examine your data, see what's in there, try to improve it. We used for text, TF-IDF pre-processing is really nice. So check this out and use that. It's a really simple idea. It assigns different weights to each word. Like there are words like in English, "the" doesn't have much meaning, but a word like itinerary have a lot of meaning. And this thing is doing that. Also, we had to do some crazy stuff. In many of the emails that contains flights, they're in attachment in a PDF. So we had to read these PDFs and feed them to the algorithm. Also, we noticed that the algorithm that we pick is not really that important. It was really all about the data. Also, when you're building something like that, look about precision and recall, and look for algorithms that allow you to trade them and figure out what's the most important metric for you. When you have such a model, there are many metrics that you can have on them, and the precision and the recall are probably the most important ones. So depending on your business case, look what is more important for you, whether it's precision or recall, and tweak the algorithm depending on that. We also find very interesting stuff, like if you train the model on more recent data, it's working much better than training it on an older one. And this is, again, because usually these websites, they send new types of marketing emails. And if the algorithm haven't seen them, there is a higher probability it won't recognize it. And one final thing when working with this ecosystem of Python is try to deploy IPython on a beefy Spot instance and collaborate on that. That was really valuable for us because it allows us several people to collaborate on these algorithms. And also sometimes you want to run some pre-processing that runs for several hours. and you don't want to keep your laptop open. You run it on that machine with a lot of RAM. It just works there. You come back after several hours, and you just see the results. So that was really amazing. Let me introduce you Michał. He will tell you about another project that we started working on, which is much harder than the classification. And this is parsing the emails themselves.
So hi, I'm Michał, and as Val told you how we're distinguishing between the emails and email tickets, so itineraries, I'd like to tell you what we're doing with the itineraries further. We don't have much time, so I won't be going into technical details, algorithms that we use, and so on. Instead, I'd like to focus on one single thing, how important it is in case of data science projects to actually understand what your business goal is. So in our case, what we were trying to do was to extract flight details from the itinerary. And the companies that do it usually notice that itineraries are created using templates. So they utilize this fact by creating for every template, creating the algorithm, usually handcrafted, that knows where is each element of a flight. So for example, airline code or departure date. Now, we would like to do the same. So basically, we would like to generate such parsers, but automatically. Luckily for us, we have thousands, actually tens of thousands of annotated itineraries. So we can use it we thought that we could use it in a very standard supervised algorithm approach. So you take the itinerary, you identify flight details, location. Just in our case, majority of those itineraries are HTML, so you use XPath for that. Once you have such a set, you know which text elements are containing the flight information. So the text element might look like this, flight UA 408. You have to have an extractor that divides it into the airline, and in this case, it's United Airlines, and the flight number, so 408. And this one is easy, but think about it this way. You have a following text. Your flight from Honolulu to Los Angeles is taking off at 5:15 p.m. on 27th of July, and we'll deal with that. Luckily, the finite number of heuristics do the job in such case. So you have a set of pairs of location for flight elements and the methods how to extract them. What you do next, you validate the quality of such algorithms. So you take a subset of itineraries from for a given template, you check the quality of the algorithm. If it meets the criteria, then you add it actually to your table with algorithms. And you take the next itinerary that hasn't been processed correctly yet. So in terms of machine learning technology, you could see that this is a boosting algorithm effectively. And actually it works. It works quite well. We have very high accuracy. Unfortunately, when we started about thinking about productionizing it, we looked at two things. The first, this algorithm is not flexible. So if we have new templates or some corner cases, it doesn't handle it well. We also ended up with quite complex code. So at the end of the day, this ended up to be very typical software engineering project. And we did what software engineers usually do in such cases. So we actually started from scratch, decided this time we'll do it better. And we looked at the problem that we were solving. So we tried to extract flight details from the itinerary. Well, it turns out that AirHelp actually doesn't need it. So in case of AirHelp, AirHelp is helping, as Val told you, its customers to get a compensation from the airline if a flight is canceled or delayed. So What we really need is just to identify itineraries eligible for legal claims. And the technical implication of this is that we're OK with false positives. What does it mean? Well, if we have an itinerary with 2 flights and our algorithm discovers there are 3 flights, the third one, well, it will be discarded by the sales, by our rep, if only it doesn't happen too often. So with this assumption, we could actually try to create a totally different algorithm. We called it unsupervised algorithm. What it does, it takes the itinerary and it annotates every element that looks like flight number or airport or time or date. And it doesn't care whether it is really a flight number. It just resembles one. There are a few neat algorithms that can do this. So when we had this, you actually end up with a large set of annotated text elements. We construct flight candidates. So let's imagine that we have a flight from San Francisco to Los Angeles, and there's departure time, arrival time, and the time when the itinerary has been created. We actually construct 3 different flight candidates out of this. And then, having that, we actually end up with a huge number of flight candidates. We go to the external database and validate if this flight really exists. And only the ones that are the real ones are added to the itinerary, and that's it. This is as simple as it is. We have our itinerary constructed. Now, it works. It's really flexible, handles new templates. The nice thing is that it's actually easy to extend this algorithm to different formats, like PDF, text formats. And the most important thing from our perspective is that the code is way simpler. And of course, there are false positives, but we knew it from the start. So at the end, if there's one thing I'd like you to remember from this deck, is that in case of data science projects, the most important thing is to pick the simplest method for solving a real problem. And the most difficult part here is actually not picking the simplest method. The most difficult part is to identifying your real business problem. Well, thank you very much.
Yeah, I think we have some time for questions. So we'll be happy to answer like details and whatever you might want to know.
Okay, thanks Valentin, thanks Michał. I have one question. What are the biggest disadvantages of using machine learning for email classification?
Yeah, so once you go down the road of machine learning, a lot of stuff is starting to change. And when you start filtering that data, you start to have a kind of a biased data that the algorithm considers is good. And it's true that when you build that model, the performance will start to decline as the time goes by. Exactly for the same reason with the ad hoc approach with filtering on subjects. Because there will be like new kinds of emails that the algorithm haven't seen. So you need to retrain that model. You need to have proper monitoring of the performance of this model. And that could be non-trivial. On the other hand, having a machine learning approach is much more robust than having any other rule-based engine, because basically you feed the algorithm hundreds of thousands of emails, entities, data, and it just learns from that. And it's much better than anything that you can do by hand. While all the other solutions might need hand curating rules and stuff, the machine learning will be much more robust. But still, you need to retrain it on a regular basis. So it's not like panacea that is going to resolve all your problems, but it will bring you on the next level. And you have different problems, but it will be much more robust. It's really powerful.
Okay, thank you very much. Give a round of applause for our speakers.